the Discovery Awards. Nominees for Emerging Professional.
Amy Bombay is an assistant professor at Dalhousie University in a joint position split between the Department of Psychiatry and the School of Nursing. Dr. Bombay is a member of Rainy River First Nation who, prior to her current position, completed her master's and PhD in psychology and neuroscience at Carleton University.
All right, ready to get to it? Yes.
And then a 2-year CIHR fellowship at the University of Ottawa Institute of Mental Health Research. Her multidisciplinary research program explores physiological, historical, psychosocial, cultural, and political determinants of well-being and mental health.
Hey, Flynn.
Hello, Dr. Bombay.
We use science to better understand how colonization has impacted the lives of Indigenous peoples, both in terms of contributing to both health and social inequities.
Dr. Bombay has led and been involved in various quantitative, qualitative, and mixed methods projects investigating factors related to well-being and mental health among Indigenous adults and youth living on and off reserve. Her primary focus has been on exploring the relationships between historical trauma, contemporary stressor exposure, and stress-related pathology among Indigenous peoples in Canada, including exploring how different facets of cultural identity are related to well-being.
When trauma in one generation affects various health and social outcomes in the subsequent generation. And a lot of our research has been looking at this in First Nations contexts.
Which has garnered extensive media interest and, more importantly,
Just really helps start that conversation within the general public and also in policy arenas and in trying to influence policies that affect the everyday lives of Indigenous peoples.
Gaelle Colelot is an assistant professor of electrical and computer engineering at Dalhousie University. She has an electrical engineering degree from Concordia University and completed her master's and PhD at the University of Toronto. With a focus on exploiting the new quantum dot technology for solar cells, as a graduate student, Dr. Colelot developed the world's first functional colloidal quantum dot tandem solar cell, employing a single quantum-tuned material.
This is my dream job, and I love research, I love being in the lab, and I love being with my students, teaching them how to do experiments and guiding them through their different projects.
She also conceived a material processing that enabled prolonged stability and improved electrical properties in photovoltaic junctions based on colloidal quantum dots. That process is now patented and licensed to Envisage Inc. Before joining Dalhousie University in 2016, Dr. Colelot was awarded a prestigious Banting postdoctoral fellowship from the Canadian government, which led to her completing her postdoctoral training at Stanford University, where she investigated the properties of single-walled carbon nanotubes and their potential in photovoltaics. Her work has frequently been highlighted in major media outlets for technology reporting, such as NanotechWeb, Materials Today, The National Post, MIT's Technology Review, and Engadget.
It is flexible, and carbon nanotubes have stretching ability as well. That means that they can be integrated in substrate or in things that are stretching.
Notably, her first research publication in the American Chemical Society's journal ACS Nano was one of the 10 highest cited articles in the journal for 4 consecutive years.
We can actually apply it into devices that are novel, and the technology is evolving. It's not always going to be rigid and circuit boards. It's all evolving, and this is what we want to be in, and we want to be pioneers in the field.
Sam Varus is currently an associate professor in the Division of Engineering at St. Mary's University and an adjunct professor in the School of Biomedical Engineering at Dalhousie University. A graduate of Dalhousie Engineering, Dr. Varus completed his PhD at the University of Auckland. Now, 4 years into his professorship at St. Mary's, Dr. Varus has supervised 5 master's students, 1 doctoral student, and over 15 undergraduate research students.
How many mineralization cycles has this gone through? I think the greatest thing about working with graduate students is just watching them grow intellectually, and then at the end, asking their own deep, very good questions that are unanswered.
A collaborative scientist to his core, Dr. Varus works closely with academics in biomedical engineering, chemistry, and physics. This interdisciplinary research has provided fundamental insights into the structural changes that occur in mechanically overloaded soft tissues.
The appeal of working in several scientific disciplines is that you meet a lot of people with really specialized knowledge that you don't have. I'm always learning something new, and we're always exchanging really valuable ideas.
In less than 10 years, Dr. Varus has made impressive strides in his research into the biomechanical failure of soft tissues at the nanometer scale. By exploring mechanical tissue damage in a novel way, with focus on the basic biomechanics of failure rather than the inflammation healing responses that have occupied clinical medicine, Dr. Varus aims to design new therapies for the treatment of tendons, ligaments, and the intervertebral discs of the lower back.
The study of soft tissue injury is important because it is such a large economic problem, and if we can figure out why those injuries take so long to heal, then we can have a dramatic impact on society.